Good day to everybody, wherever you are. We hope that you are joining from all over the world. And welcome to our next event within the Bond series of presentations. Today, the focus is on the operations in a clonal crop breeding program. We won some presenters who kindly offered their support from Europe, from Poland in particular. I come to that in a moment. But first, let us pledge a word on our own behalf here about Bond. Maybe Amir, you want to come in here and briefly?
Yes, sure. Let me share my screen for a second. Okay, just to mention the Breeding Operations Network for Development, which is the BOND, and this is a series of developments that we have established as Excellence in Breeding Platform Module 4, and the reason for that was to help the breeding operations to develop and improve the different practices and establish community of practice among the breeding community within our CG as well as our NARS partners systems. I'm just going to go briefly through the bond, as we have certain pillars for our initiation or program, and those are the bond one-on-one interaction groups, and this is one of the sessions that I personally lead the seed processing, and my colleague Vinicius leads the irrigation and drought tolerance. Okay, and we are working with different groups, different breeding operators on those types of developments, optimizing operations, etc. We have the bond webinars, and this is one of our bond webinars that we have been conducting, and there's also the e-learning modules as well as the technical visits that we hope to achieve through different workshops, and we've had 2 workshops within West Africa as well as East Africa. So our aim is to, again, optimize our breeding operations and phenotyping, and we need to reach a certain target and establish a certain community of practice within our bond system. I just want to remind, like Bodo said, that everything is being recorded, or our webinars, our interactions, or even our trainings, they are all recorded, and you can see those on by logging onto the Excellence in Breeding website. You can check through the videos or through our YouTube channel, okay, which is also through Excellence in Breeding YouTube channel, and we have a special playlist for the bond operational webinars where you can access the different recordings or the different webinars that we've had. And that's it for me. Thank you so much for attending, and hope you enjoy this webinar. Off to you, Bodo.
Yeah, thank you, Amir. For those who do not yet know, Amir Naim is with EIB originally. He is stationed in Ghana, and he is assisting Gustavo Teixeira for West Africa in the area of mechanization operations. And my name is Bodo Trognitz. I am the breeder West Africa. I'm stationed at Ibadan, Nigeria, and I work with all breeding programs of the CG across West and Central Africa. So we work together. Welcome to those who have joined recently to this call. This is now a presentation on operations in the clonal breeding program. We got an example from the potato from Europe, and I am quite certain it will be very interesting, in particular for our breeders of clonal crops, how to manage this. And may I introduce briefly our presenters? We have Renata. Dr. Renata Lebecka is with Poland's National Plant Breeding and Acclimatization Institute. She holds the position of head of a potato pathology lab at the Department of Genetics. She has been researching potato in the context of genetic enhancement since more than 3 decades. And today, she will present the operational work at one of their breeding stations, Zamarte, together with Piotr Kaminski, who has been a long-standing potato breeder himself, and he is now the director of a Zamarte breeding station. We also greet Alexandra, who is together with Piotr today. So with these words, I would like to invite our presenters to start. If you don't mind, over to you, Renata. The floor is yours.
Thank you very much, Bodo. Thank you, organizers, for inviting me to present on behalf of the president of the Zamarte breeding station, this presentation, which we have prepared together. So at the beginning, I would like to show you a very short video, which will, let's say, introduce you to the company from the bird view, yes, or in some very really short video. So now I need to make ekran tu.
Share the screen.
Yes. Share the screen. It should come. Can you see something?
No, not yet.
Maybe now.
Now it comes.
Okay. Yes. Okay. So now I will start. So breeding Zamarte station is located, as I told already, near the lakes and forests, and this is the farm from the bird view, and you can see the office, the main office entrance, and some greenhouses. And the seed production starts with the in vitro plants. So there are laboratories with in vitro facilities. So microtubers are produced as a clean material, which is diagnosed for some diseases. And the seeds then are planted in pots. Also for inbreeding program. No, there are potato fields here shown, and the breeder is doing selection and the description of the clones, and the fields also from above, some digging potatoes, which I will show in details in my presentation. And the potatoes are selected also in the field, first selection. And seed production, seed tuber production, the potatoes are harvested with a combine, big machine. And there are 5 people who are operating, removing the stones and some parts of plants. And the potatoes then are in the storage. They are also cleaned again and put into big containers, wooden containers. And then before selling on the seeds, they are packed, or before planting, they are packed in rational bags. The storage is climatized, it's a set temperature to 4 degrees Celsius for seed potatoes. and 80–90% of humidity. Then potatoes are packed for selling or for planting, depends on the purpose. And the storage capacity of Zamarta is quite huge, it's 9,000 of tons of potatoes, and the biggest storage is 3,000 tons. So it's quite huge. So this is it about the video. And now I will start my presentation. One moment. Whoops, sorry. It's not the beginning. I need to go to this slide. So you could see already the main building of the and some other photos which already shown. But I would like to mention that the solar panels supply the station with partly in winter time and fully during the summertime. And the enterprise is actually potato breeding Zamarta is supervised by is owned by Plant Breeding, my institute, but supervised by Ministry of Agriculture. And the main production of potato and breeding is located in the main center of Zamarte, but potatoes are also grown in 2 other stations and also by licensing agreement system or in individual farmers by contracting agreement system. So the arable land of the company is more than 2,000 hectares, and the value of structure share is that 64 are fixed assets and 22 is equipment and machinery. And it's worthy to mention then annual investment is about 20% a year of the company value. In addition to the main activity of the station, that is breeding of new cultivars, there are many other activities, and this is production of pre-basic seeds of own cultivars and production of elite seeds. There is distillery of potato alcohol, and there are grown other agricultural crops which are used as rotational plants as well. Potato grows every 4 years in the same field. I would like to show that maybe I can remove this, that the potato is the 4th largest food crop in the world. And potato cultivar actually is a vegetatively propagated progeny of the plant, which is obtained from only one seed. And in Poland, we have snowy winter and only one vegetation season a year, which starts in May and ends at the end of October. It means half of the year. In potato breeding station, for the last 76 years, 114 cultivars were released. And from that, 30 cultivars are in the national list in present. The breeding programs is led in 4 main directions: for table quality, and there are traits which are most important in selection: short vegetation period, suitable for washing, packing, with different flesh colors from white to violet. The other direction is starch cultivars, and the most important traits are pest and disease resistance, suitable for industry, for French fries, chips, and dry potatoes, and also one direction, which is organic potato, which means also they must be resistant to some diseases. On this slide, I would like to show you and stress how complicated breeding of potato cultivars, that every year in the year of breeding, there are different generation of breeding process. So to breed one potato cultivar, we need 11 years at least. So in the first year, 0 year, we have crossing programs, which we cross the potato selected parents. And this number is about 400 different crosses. The next year, we plant seed plants from the single seeds in pots, and these are on the level of 70,000. And then each year, the number of clones decreasing and end up with 1 or 2 cultivars, but with each year, the number of tubers from one clone increasing. And at the end, for advanced clones, we need to multiply as much tubers as possible. So you can imagine that every year it is 10 different cycles of selections, because in each year we have crossing program and the first, second, etc. All these generations. So the crossing program is run every year. 400 plants of 80 female parents and more than 100 male parents is used for this in this program. So 400 combination of crosses are done every year. And this crossing program is conducted by only one lady. Not all crosses are successful, so out of this 400 combination, 200 are selected for seed plants that are grown in pots. The most important for breeder is to select proper parents for crossing. And every year, this is a constant process, and every year breeders are looking for new sources of genetic, to have a wide genetic variation in their parental materials. So there are quite high potato plants because the top of plants are grafted on Solanum nigrum plants to intensify flowering. So we have many flowers on each plant, and also for pollen it's important to collect the pollen. When the berries are soft enough, the seeds are extracted, and then they are collected in tubes and seed. They are sown 350 seeds per population, and from this 400 combination, 200 are selected to be sown. It gives 70,000 of seed plant in pots every year. From this, only 1 or 2 will become a cultivar after next 11 years. So it is really a hectic work. This is an example. On this photo, you can see tubers of one population, because from each pot, only one tuber is collected. And this is one population. And this is an example of quite high genetic variation of parental forms used for this one cross. But there are also tubers which you can see they are more uniform. This is the photo of the breeding field. and from the above, and you can see that there are many different parts and different, so all these 10 generations of breeding cycles are placed in this field. How it is being done? I don't know if it's okay. Yes, so there are wheels, steel wheels, which are with a tractor, which make these lines on the field, and then another beam with the wheels, because this is 35 centimeters. Another beam has only 4 wheels, so and they are creating the rows, ridges, which are 75 centimeters in distance. And here you can see that the seeds are planted, by hand. So each tuber actually has own place in the field, and in the plan, which is made on a card of paper, every tuber is described where it is in the field. You can see that the tubers are pre-sprouted before planting them. Okay, so in seed production, when we want to multiply more bigger fields, for planting a planter is used. And then the planted potatoes are covered with the soil with the use of ridge former. They are nicely formed, and it looks also very nice. Mm-hmm. Then there are spraying is done during the season here with herbicides, but the number of sprays is with insecticide, fungicide, fertilizer is around 10 times per season, with seed plantation even more often. Mm-hmm. Here on the photo, you can see the emerging of plants, and photo of the first clonal generation as an example, 4th clonal generations, and bigger plots, blocks. The potatoes which are planted here, the handwork, because the ladies collecting digging up potatoes from some experiments, but also the first generations in the field are harvested by handwork, because there is no specialized equipment which is maybe not too expensive. It's not working very well. The company has bought one, but the tubers of 2 plants were mixed, and they should have distance 1 meter apart from each other, not to be mixed. So practically the equipment is not working good enough. Digging potatoes in rows can be from 1 row digging. You can see here that the 2-row digging there is a special separator done by the company, let's say mechanizators, that each row is harvested separately. Mm-hmm. But also there is oh my God, there is a 2 rows digging, and you can see that there are quite long, and it must be bigger multiplication here. But the small one, they are always harvested by hand. So in
We
such
just see we just see the one row digger. Yeah, good. Okay,
yes,
go.
okay. And on this photo, you can see that there are some potatoes and they are collected in the bags. But also I wanted to show you the notebook of the breeder. It's the most important for selection and because to take the decision which potato is taken to the storage, you must have all the data which you have collected also in the past. And with this book, you can make the decision. So all tubers which are negatively selected, they are left in the field and they do not go to the storage. The other, they are collected and they are put already in special containers, and these containers are then loaded in the storage rooms. And you can see that also ladies are working here. They are seasonal workers. Here in the storage, you can see already some samples which are taken from the breeding clones for more advanced clones for some quality, like taste quality or some darkening potatoes after cooking for testing in the kitchen, let's say. Also, potatoes are stored in 1 ton wooden containers. And on this picture, you can see the scheme of selection that in each year, there are different traits assessed. Because here we have only a few tubers, so we can make size, number of tumors and size of the plant, but not many more. But the same with the clones, but then it starts another evaluation. So in the 6th or 7th year of the selection, there are already national trials in 8 places, and registry trials, they are in the 9 and 10 years. What kind of traits are evaluated for these breeding clones? So most important, external quality. I will not read them all, but they are written here. Some internal quality, some agricultural, which are very also important, and resistances. And as I have mentioned, for each direction of breeding, the stress to select the potatoes are different for different traits.
Yeah,
here, yes.
Sorry that I come in here. Maybe it is worthwhile spending a minute more on this last slide that you showed on the traits. For example, the trait vegetative period. How important is that? How does it come into play?
Okay, the length of vegetation period is most important more for the table quality potato. Not so much for starch potatoes, yes. So it is evaluated, I am sure, with the time of senescence of the plants usually, isn't it, Piotr?
Yes, I agree. The length of vegetation period is very important for tail potato, not so much important for starch, but we evaluate this every year by watching plants and by watching yield in the term of digging.
Yeah, okay. So the yield is evaluated. Yeah, so
But
for example,
you are showing these trade complexes in this sense, right? Because somehow there must be more individual criteria.
of course, that sometimes you can find some highly starch crop which is not so which is early crop, yes, but usually it is like that, and that time of how you call it the not saving, but the starch is
Content is too low.
yeah, content is growing up with time usually, so it is like that. But okay, cooking type is important for industrial, for French fries, from chips. It's more important, not for the starch potato. Again, resistance to viruses is important also for every kind. It would be nice to have all these traits on a good level, but it is impossible to select for so many, to find all these.
How many resistances are you selecting for?
For viruses, I'm sure, for
how
late blight, wart, nematodes, these 4.
Okay. But and how many viruses diseases are you selecting?
Actually, I would say that the Polish parental lines, they are characterized by very good resistance, extreme resistance to PVY. Leaf roll virus is not as important in present. It was important many years ago, so it's not important. And PVS is actually very, let's say, annoying virus, because it causes very light symptoms, but it's very difficult to remove it from the seeds, from the it's quite difficult for the seed production, I would say. But there are no extreme resistance for PVS.
Yeah, thank
Piotr,
you.
you would like to add something to it?
No, I agree.
Okay.
Important virus is PVY now.
Yes.
You have no problem with leaf roll, and PVS is important for qualification, for certificate to achieve a good material. Yes, but difficult to obtain by combine with resistance parental forms. To obtain resistance to PVS is difficult.
There are no good sources of resistance because the selection was not being done for many years for this virus. Now it appeared to be important. Okay, so let's go next, because it's also about the kitchen and some darkening of tuber flesh and some other characteristics. So you can see here that, sorry, not here. That, for example, this cultivar is more dark, and also this one is not desirable trait for table cooking quality. So it is done just in the kitchen, and also, sorry, in Poland, in Zamarte, they make this darkening of tuber flesh in potato pancakes. So you can see that there are different colors. They are really variable, and also some juice with from potato, and how it is darkening with time. Also, chips color is evaluated, and also some samples can be collected for example, flavonoids or carotenoids content in tubers, and they are frozen in liquid nitrogen before evaluation. And what I would like to also mention that it is very important, and that the breeding station in Zamarte has been using the molecular markers for selecting extremely resistant potato plants to late blight, which is caused by Phytophthora infestans. And you can see in the field that when the weather is favorable for Phytophthora development, it can destroy completely plantation even in 2 weeks. And the number of sprays is around 10 or more in years where the late blight is a problem. And here you can see some leaflet test, and you can see that drop inoculated leaves, they are infected with Phytophthora, but some are not. And these have the R genes, which are effective for this pathogen presently in Polish population of Phytophthora. So what has been done? The 4 different genes which are effective, but to avoid the breaking of this kind of resistance, the pyramiding of these genes were done based on these markers, DNA markers, and they were confirmed with these previous tests, which I have shown already, that these markers present, and the leaves just looked like these resistant ones. So using these markers, the first cultivar, which is bred for organic production, was released. It is called Gardena, and this cultivar is resistant to late blight, so the 10 sprays can be saved. In organic production, they are not sprayed against Phytophthora. So the potato cultivars which are bred in company, there are also multiplied as in vitro plants, and this in vitro starts in 8 and 9 years, but to the gene bank is duty to send in 10th year of breeding cycle. So there is a huge, let's say, quite big laboratory to multiply these plants, and they are multiplied in greenhouses to obtain mini tubers. And these mini tubers are here. And to tell you how much how many of them are produced. So this is an example of cultivar, and there are 30 cultivars which are multiplied in the farm, and each of them, let's say, about around 30 tons a year is being produced every year. And for the best cultivar, 1,000 tons of this seed potatoes are produced. So this is another example of cultivar Provita, which was bred lately, and it has violet flesh, and it has a very high content of anthocyanins, which are phenols and very good for health. And this cultivar is 2 times more expensive than just creamy or yellow potato. And at the end, I would like to leave you with this slide where you can find the contacts to breeding company. So if you have some questions, or maybe you would like to have some cooperation with this company, you are welcome. And here with this slide, I would like to thank you very much for your attention.
Thank you. Thank you so much, Renata. Yeah, this is quite, how should I say, impressive, this potato work when one looks at it. And this is probably more than 1/3 of the potato breeding work that is done for the big country, the big population of Poland, which has been successful since more than 100 years. And it's quite interesting to see how you guys manage the operations of this. So you have some parts that are mechanized, others are less mechanized. You are maintaining a good balance between these the levels of investment and the levels of output. Yeah, thank you so much for that. So the floor is open now. We have some, I would say, 10 minutes left for a brief discussion. There are a few questions in the chat. Maybe those who have typed there want to tell their question themselves here. Otherwise, we can also read them, but so I don't
there
know.
are some.
Let us read those, Bodo, and maybe we can, if anybody wants to ask verbally their question, they can unmute and ask it afterwards.
Good. Okay, let's do it that way. So let's start with a person from the potatoes, which is Hannele. And her question is, how do you evaluate the different disease resistances? Are these done in greenhouses or field trials? Please.
Piotrze, pytanie jest, jakie odporności na jakie choroby są oceniane i czy to jest robione w szklarni czy w polu?
Czy możesz odpowiedzieć? Bo no tak.
Mogę.
No więc obecnie odporność na Y no, testujemy tylko w Młochowie, natomiast sami dysponujemy taką bazą form odpornych, że nie badamy tego.
Okay, so the answer is that the only disease assessment is for PVY resistance, and this is done actually in our center, in our genetic departments, because we have field trials here where the aphids are, and we also put some sources of infection in the field with PVY virus. So then they are evaluated as a natural infection, but also eye probe is being done in the greenhouse, and the plants from the which originate from these eyes, from tubers collected from the field, are tested for PVY, and this evaluation is being done for all the new cultivars which are in registered trials. So the results are just passed to the breeder, and the parental forms which are in use by the breeder are already known for what kind of resistances they have. So actually they do not evaluate disease resistance in the company.
Yes, obligatory for us is resistance to wart diseases.
Yeah, that's true. And this one is being done in quarantine laboratory at our institute, but in other center, where they test for many pathotypes of Syncytium and the Bioticum, and also for nematodes. Yes or not now?
No.
Dla nicieni też?
Yes,
Yes, for nematodes. So this kind of evaluation also not in the station, but in our institute.
Okay, thank you. So there are several questions on the aspect of modernization and digitization. You mentioned in the beginning that 20% of the annual income is reinvested into research and development. And so this question addresses the aspect of how do you deal with modernizing your procedures over the years, and also because we saw that you are recording the data using field books. Are you also working on digitizing data management over time?
Every year we collect about 4,000 to 50,000 data, and we collect this in Excel program, and przetwarzamy przez programy do oceny doświadczeń, no ale.
And there are special statistical programs to analyze data to select this data, the best one, the best clones, yes. But as far as I know, any digitizing equipment is not being used in the breeding, but the breeder's eye usually, because because the plantations are protected chemically, yes. So there is no and the look of the plant and how it looks and tubers is being done without any digital equipment.
Powiem po polsku, a przetłumaczysz. Nie wiem, ilu jest hodowców wśród osób, które nas słuchają. Natomiast jak niezwykle hodowcy wiedzą tylko, jak niezwykle istotne jest doświadczenie hodowcy, które zbiera przez lata, pracując na materiale pochodzącym z własnej hodowli. Dlatego tak istotne jest to, że Zamarty istnieje aż 75 lat i w tym czasie zgromadziło materiały, nad którymi pracuje. Natomiast nie ma żadnego programu do tego, żeby na przykład ułożył program krzyżówkowy. To we własnym umyśle dba o to, aby znając potomstwo wykonanych przez siebie krzyżówek, mógł ocenić, które z nich przekażą te cechy następnemu potomstwu.
Może ja nie zapomnę. So actually what Piotr wanted to say that during this 75 years of breeding in Zamarte, the parental forms which are the most valuable are very well known by the breeders, which have rich experience, and any of programs is able to select the best parents for crossing, because the let's say the combining ability is assessed by the breeders, and they know which crosses are promising crosses.
Good. Thank you.
Maybe Jarek, you wanted to add something to it.
I think that it's very also is very important that the breeder with like Piotr with a long period of experience have own let's say breeding gene pool, and he know it's very well, and it is also very important, and there is no let's say statistical programs on any other equipment, I don't know, which can let's say plan for crossing programs better than breeder with the long experience.
Yeah, so thank you. So now before Thiago gets a chance to ask his question, he raised my hand. There's one, I think this is a good leading now to this question on genotyping. Have there been done some genotyping experiments in your breeding populations? How do you develop these populations over the years? And also, do you test them on more than one site? And yeah, this one, please.
Poproszę was, żebyście odpowiedzieli. No, nie robimy tego genotypowania.
No, the genotyping is not being done. The clones are they are tested in 8 locations before the national registration. I don't know how many locations in national registration. Coboru, in many localization they test clones.
Coboru zaczynają tego roku.
Ale w ilu miejscowościach testy?
8.
Also 8, yeah, 8 localities, and that's it. No,
I think that the question is for the about the genomic selection, but in the potato is the far future. I think that the genomic selection
it is tetraploid, very heterozygous, and
it's very difficult to apply genomic selection.
We are doing at our station. We are working with diploid populations, and we have been mapped many traits, but for breeder, very important traits are quantitatively inherited, not qualitatively inherited. And mapping is also time-consuming work, but is easy to be done now with sequencing, etc. But for quantitative traits, it is still not easy, and with these many QTLs which are maybe working at the diploid level, but not in the cultivars. They are useless then. So it is not really important task.
Thank you. So I see we have 2 minutes left, and maybe we can use this. So Thiago, you can ask your question now. And then after that, there's a question on the population size. So how many, so you say you do so many hundred crosses, and you raise so many hundred F2 progenies for selection, and then is this size adequate to the market segments, the market size for your potatoes, with, for example, the purple flesh? But before you answer this question, perhaps Thiago wants to come in here, please.
Okay, thank you so much. This is Thiago from International Potato Center. I'm based here in Africa, Kenya. I think some of the questions I had, it was already raised in the chat box. It was about this population size. My question is to know if there is any rationale behind of that 7,000, seedlings that they start the program. And also, I just would like to know a bit about the parental selection, in the sense of if they're still using like old parents, that for the breeder, it's still important to use, or if they are only using very, very new or doing some kind of fast parental recycling. Thank you.
Yeah, this is, I think, a very valid question here.
I didn't hear properly, maybe because of some echo, but can you, Bodo, simplify the questions, please?
Why just 70,000 seedlings in every year?
Mm-hmm.
And how does this relate to the uses of these potatoes? So is this something that has been figured out? Is it enough? Would you like to have more? What is the background of this?
Piotrze, zrozumiałeś?
Tak, zrozumiałem. Jaki jest, dlaczego jest 75
No.
tysięcy? Ale odpowiem tobie, dlatego że rozmiar hodowli to jest liczba siewek, jest rozmiarem potencjału hodowli. I to są, przekłada się to na koszty, które musi ponieść spółka na hodowlę. Kilkanaście lat temu, jeszcze 20 powiedzmy.
Stop. Może. This is arbitrary to set the let's say the biggest possible to manage number of seeds every year and to be able, because it costs money as well, to manage it well, let's say, with to be able to control the process. Yes, as much as better, but you know, it's not possible to. And
Yeah,
okay,
Można
does it answer your question, Thiago?
No, it's not yet answered, but I wanted to translate in part. So please, Piotr.
20 lat temu, kiedy hodowli stawiano wysokie zadania, jeśli chodzi o odporność, czyli wysoki poziom odporności musiały mieć odmiany, to ten rozmiar hodowli wynosił dla każdej jednej 150 tysięcy. Natomiast przekłada jednocześnie na bardzo dużą powierzchnię pola, na której trzeba przeprowadzić wszystkie doświadczenia. Nasze pole to jest 20 hektarów ziemi, to jest średnie gospodarstwo rolne w Polsce, więc...
Okay, maybe stop. So the demand and okay, we know that potato cultivar must be better than the existing ones, yes? So many years ago, there were different expectation, let's say, levels for resistance to diseases, and the size of population was even higher. It was 150,000 of seeds, and now the requirements for resistance are smaller, but the company has also not so big field to be used. Yes, it's like 20 hectares for that. So they set this size of population on the level of 70,000.
And not to forget that you have just less than 10 people available for work.
Okay.
This does not change. So I see the time is up. If there is no other burning question or something that we may have forgotten extremely, I see Elisa Salas is asking a question. Maybe we can answer this after it via email, if you agree. And so we would like to thank all the participants today, and thank you so much to our presenters. It's very nice, and it's so kind that you have offered this to us. We understand you are a kind of commercial enterprise, and it is very rare that we get access to this information. So thank you very much for that. And so we are looking forward to other events in this Bund series. And with that, thank you very much to everybody. Enjoy the rest of your day, whether it starts or ends. Let's see, and hope to see you again soon. Thank you so much.
Thank you.
Thank you.
Thank you.
Bye-bye.
Thank you. Bye.